Hello again. This is the second half of 8B's lecture. Everything we did for doubling, we're now going to do for the half-life. Okay? So here's the formula. It's exactly the same, except this is a half instead of a 2. Okay? Because we're cutting things in half. So you could be an archaeologist or a paleontologist or an Egyptologist, something like that. You discover a dinosaur bone, and it originally had, say, like 10 grams of marrow in your arm, the dinosaur's arm, and we've discovered it 1,000 years later, and there's only a portion of that. Well, we can take that portion, 0.26 parts of marrow, and we can check the age of the dinosaur. So it also works with chemistry. That's what we're going to do right now, okay? We have a chemical concoction of 10 grams of this chemical, and it evaporates, okay? And every 3 hours, it cuts itself in half. So after 3 hours, we have 5 grams. After 3 more hours, now really 6 hours, we have 2.5 grams. After 3 more hours, which is 9 hours into the experiment, we have 1.25 grams. Okay, I could go on and on and on, okay? So what we want to know is, if we start with a certain amount, and we know the half-life, that's what it's called, half-life, and we know how long we run the experiment, how much will we end up having? So for instance, your number 46 on page 508 says, the current population of a threatened animal species is 1 million. So it's the current population is 1 million. That's your initial. But it has a declining half-life of 25 years. Okay? How many animals will be left in 30 years? So we have an initial population of 1 million. How many zeros are in a million? Remember, it's 6. Okay? 6 zeros. Okay? Put it in the comments for me. Okay? The half-life of these animals is 25 years. Time to have 25 years. So that tells me today there's 1 million animals. In 25 years, there will be 500,000 animals. In another 25 years, which would make it 50, there'll be 250,000. In another 25 years, that makes it 75, that will make it 125,000. And you can see it's definitely dwindling. Okay, so, but I don't want it at exactly the 25, 50, 75 mark. I want it at 30 years. So you're going to say the new amount is equal to 1 million times a half to the little t, the time to run the experiment, over big T. Okay? And those both have to be in parentheses. Okay, the answer to number 46 is, well, 30 years is just a little bit more than 25, so it should be a little bit, if this is 25 years, makes it 500,000, 30 years should just be a little bit less, and it's about 435,000 animals, which is just a little bit less than 500,000. So that's the half-life. Okay, that is finding the new amount. Okay. Well, you know that handy-dandy little formula of rule of 70, it works for half-life as well. the time to have, if you have to find it yourself, is equal to 70 divided by the percent. Okay? So, your number 50 says, a cleanup project is reducing the concentration of pollution in the water supply. It decreases by 3.5% per week. What is the approximate half-life? Okay. Doesn't say anything about how much you started with, doesn't do anything. It just says it's decreasing. Decrease is always half-life. Okay. We only study doubling in half-life, okay? Not quarter life or anything like that, or tripling. It's decreasing by 3.5% per week. Okay, what's the half-life? The time to half is equal to 70 divided by 3.5. Again, you notice I didn't make the decimal. I didn't make it 0.035. So I do that out, and I get 20 weeks. Okay? So if I started, if there was 100 pounds of trash in the river, in the Colorado River, in 20 weeks there'll be 50 pounds. In another 20 weeks there'll be 25 pounds, until it dwindles down to just a small fraction. Okay, the second half of this problem says, by what fraction is it reduced? Okay, so again, that's just this part. It doesn't tell you how much you start with or anything. It just says, by what fraction is it reduced? 1/2 to the little t over big T. By what fraction is it reduced in 1 year? In 1 year. Well, I'm talking about weeks. So I have to convert my year to weeks. So it's 1/2 in parentheses to the little t. Time to run the experiment. 1 year, which is 52 weeks, divided by the time to cut it in half, which is 20 weeks. This is the factor. When you work that out, with parentheses around both, it becomes 0.18. Okay? I'm sorry, those are my dogs. It's too cold for me to put them out on the porch where they usually go, but I guess they're helping you learn today. They would like to help you learn today. So we have really 6 formulas. 2 for this, 2 for this, and 2 for this. But this is a 2 in the other formula. These are exactly the same. And this is a 2 in the other formula. So I would really like you guys to work on your 8B homework assignment. Send questions, because there isn't a quiz for 8B before the test. On Wednesday, I'll be uploading your quiz, which is over 7E and 8A. And if you don't receive it on Wednesday, please email me. I'm getting a little concerned. Then I will, over the weekend, I'll upload your review sheet for the test, which is on the 22nd, I believe. Okay? So that's it. I will talk to you later, and send questions, email, phone, whatever. Bye-bye.